Hello everyone. We are Group 1 for the Pattern Recognition Practice Project. Today, we are really excited to present our project, the Skin Condition Analyzer. Our team consists of Jingrong, Weilu, Johan, Brian, and myself. On this slide, you can see a detailed breakdown of the work items each team member was responsible for. We all contributed to the research and ideation phase. The team's efforts were distributed across front-end, back-end development, API integration, AI model training, dataset preparation, deployment, and creating the final reports and demo. So let's start with the core problem we are trying to address for this project, the diagnostic bottleneck. Have you ever, sometime in your daily life, wondered like what happened to your skin? You may take it not a big deal, but actually, the early detection is critical to the disease treatment when it comes to the skin. For example, when localized melanoma is detected early, the 5-year survival rate is 99%. But if that same cancer spreads, the survival rate drops to as low as 25%. Another problem the public is facing is the long wait to see a specialist. Patients face a growing shortage of dermatologists, and average wait time for an appointment can be over 30 days. And it could cause a series of consequences: delayed treatment, higher costs, and preventable mortality. To help address this problem, we came up with this idea and developed the Skin Condition Analyzer. This is an accessible web application designed to provide an intelligent, preliminary assessment of skin lesions. Its purpose is to help users make informed decisions about their health. It's crucial to note that this is a decision support tool, not a diagnostic replacement. Our goal is to empower users and encourage them to seek professional follow-up sooner, not to replace the expert opinion of a doctor. Our application has 3 key features. The first one, AI skin detection. A user can upload an image, and our model analyzes it. It is trained to identify 7 different types of skin conditions and draws a bounding box to show the user exactly where the detected lesion is on the image. The second one, AI medical explanations. After detection, the user can get a simple AI-generated explanation of the condition. For example, the term basal cell carcinoma. Do you know what is that? So our tool will explain it in easy-to-understand terms. Third one, nearest clinic recommendations. This feature is to encourage professional follow-up. The app users can use the user's location to find and list the nearest dermatology clinics in Singapore. Now, we will move on to a live demo of the application to show you how these features work together. The first thing any user sees is our medical disclaimer. This is important. We immediately set an expectation that this is an educational tool, not a replacement for a medical professional. To proceed, the user simply clicks, I understand and accept. And now we land on the main analysis screen. The process is simple. Upload a test image and analyze. With the image uploaded, you can see this is how our AI model processes our data. and gives us three pieces of information. The first one is the annotated image, shows a bounding box around the area of concern, visually confirming what the AI is focused on. Second, the condition identified. The third piece of information is the confidence score. Now is 96%. This gives the user a measure of the AI certainty, which is important context for their next step. More features to come on is the condition info, as you can see from the right part of the screen. This is generating a concise AI-powered explanation and easy to understand. So the user will know what this condition is, its typical experience, sometimes the strong recommendation to seek immediate professional evaluation. The analysis and education are valuable, but the most crucial feature is providing a clear next step. This is where the Find Clinics Near Me function comes in. By clicking this, the app uses the user's location to offer location-based recommendations for nearby dermatology clinics or hospitals, immediately closing the loop between potential concern and accessing care. In summary, our skin condition analyzer delivers a seamless, responsible, and actionable user journey. From uploading an image, accepting the medical disclaimer, receiving AI-powered analysis, gaining educational context, and finally getting a clear path to professional care. As you saw in the demo, the user gets a seamless flow from uploading an image to understanding the potential issue. Now let's look at how the system is designed that makes this possible. This diagram here shows our complete system design. Let's work through the runtime flow, which is shown by the solid line. The user interacts with our front end, built with React and Tailwind. They use the image upload interface to send a post request with their image. This hits our backend, which is built with Fast API. The server handles image processing and sends it to the AI model for detection. The AI model is a YOLO V10 Nano that loads pre-trained model weights. It detects one of the 7 classes and returns the bounding box information. The results are sent back to the results or clinic service on the backend. This service also queries our data layer for nearby clinics from our database and uses the Olama AI assistant to generate a medical explanation. Finally, the results, disclaimer, explanation, and clinic lists are all sent back to the front end for the user to see. The model training pipeline shown at the bottom was our offline process. We used a skin lesion dataset, applied segmentation and data augmentation, trained the YOLO V10 model for 400 epochs to create model weights file. A critical part of our project was finding the right model. We compared 2 main approaches. Approach 1, a custom CNN. This is a simple classifier. It would only tell the user if the condition was present. Approach 2, YOLO V10 Nano. This is an object detector. It not only classifies the condition, but also provides localization, telling the user where the condition is. So which area is the melanoma, for example. The bounding box feature is a significant improvement for the user. We also evaluated both on a 200 sample validation set, and the results made the choice clearer. The YOLO V2 model achieved 93% accuracy, correctly identifying 186 out of 200 samples, compared to just 78.5% for the CNN. It also had a higher average confidence, around 90.10%, and a smaller model size. Although the inference speed is slightly slower, the 15.5 jump in accuracy and the essential localization feature made YOLO V10 the clear winner for our application. In conclusion, our skin condition analyzer successfully addresses the diagnostic bottleneck by providing an accessible, intelligent preliminary assessment tool. By leveraging a high-accuracy YOLO V10 model, we not only identify potential skin conditions, but also show users where they are, provide simple explanations, and directly connect them to nearby dermatology clinics in Singapore. This tool empowers users to make more informed decisions and seek professional help sooner, which, as we saw with melanoma, can be critical for survival rates. That's all for the whole presentation. Thank you so much for your time.